In this video, we're going to discuss derivation of the sine derivative. So we are going to use our definition of a derivative, f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x divided by h. And we're going to use that to determine the derivative of the sine function. So the derivative of f of x equals sine x. Let's begin by writing this out. So we would have f prime of x is the limit as h approaches 0. F of x plus h, that's going to be sine of the quantity x plus h minus the original function sine of x, all divided by h. So what we need to do here is we need to simplify this whole expression so that we can evaluate the limit at h, right, as h approaches 0. And we can't plug 0 in yet. So we need to go back and remember some of our trig identities. Right here we have sine of x plus h. So that's sine of a sum. And we know a sine, sum, and difference identity. So working through this, I'm going to expand sine of x plus h, right? So just this part, sine of x plus h. That would be sine of x cosine h plus cosine x sine h. And that would still be minus sine of x, all of which is divided by h. So I used my sum difference identity for my sine function there, was sine sum identity. All right, so now we get a little creative with our rearranging. I am going to have both of my terms with sine x. I'm going to pull those together and kind of unadd as well, which is easy to do when I have just one term in my denominator. So this is legal. I'm going to rewrite this as the sine of x times the cosine of h minus the sine of x. So those come together over h, and then I would still have plus the cosine of x times the sine of h over h. So this term was left still over the h. Now, looking at this first piece, I can factor out a common factor. You'll notice that I have two sine x's. So I'm going to factor out a GCF. Oh, I'm missing a 0 there. We've got the limit as h approaches 0, factoring out that sine x. That leaves me with the sine of x times cosine of h minus 1 over h plus cosine x sine h over h. Now, remember, we want to find the limit as h approaches 0 of all of this. And the limit of a sum is the sum of a limit. So essentially that limit could distribute to both of these two terms that we have, the first and the second. Also, we're finding the limit as h approaches 0. So x has no relevance to us. We're not going to be evaluating that in this situation. So the sine x, once I distribute that limit to this term, the sine x can come in front, and distributing the limit over here, my cosine x will come in front. So let me show you what that looks like. I can rewrite this as sine of x times the limit as h approaches 0 of the cosine of h minus 1 over h plus cosine x times the limit as h approaches 0 of sine h over h. So we have two small limits that we need to determine. This limit we learned in a previous chapter, that is going to equal 1. So we have essentially cosine x times 1 here. But we need to do a calculation to find this first limit. So in order to do that, I'm just going to pull this out, do a little separate calculation here for that. I'm going to say, well, I have the limit as h approaches 0 of cosine h minus 1 over h. Now, in order to simplify this, and this is a strategy we use often, I'm going to multiply by the conjugate, cosine h plus 1. The conjugate is determined when that minus in the middle turns to a plus, or if we had a plus, this would be a minus. Now, I can't just multiply by any number, but I can multiply by 1. So if I put this over itself, I have 1. That gives me the limit as h approaches 0. Foiling the numerator, I have cosine squared of h minus 1 over, and remember we don't generally multiply the denominator, cosine h plus 1. If we look at our numerator here, we notice this is a Pythagorean identity. This is equal to sine squared h. So I'm going to write that. I now have the limit as h approaches 0 of sine squared h over h times cosine h plus 1. At this point, if I get a little creative with spreading this out, I have the limit as h approaches 0 of sine h over h times sine h times 1 over cosine h plus 1. So basically I've just factored this and spread this out. What we know is the limit of a product is the product of a limit. So essentially I can take the limit of each one of these factors. As we stated up above, the limit as h approaches 0 of sine h over h, that goes to 1. The limit as h approaches 0 of sine h, that's the same as sine of 0, and that sine of 0 is 0. And then plugging in here, if I plug in my 0 for my h, I end up with 1 plus cosine of 0 is 1 plus 1, so this limit term would go to 1/2. And if we look at that product, the product of 1 times 0 times 1/2, this limit goes to, or is equal to 0. So I'm going to erase this work and scroll back up and write 0 for that limit. So looking at what we're dealing with, we just proved, and you can rewind and look at it again, that this limit would go to 0. So what we have here is I have sine of x times 0 plus cosine x, and that is times 1. Well, anything times 0 is 0, and I end up here with cosine x. Now, what was on the other side of my equal sign? That was my derivative. So essentially what we have proved is that if we are given f of x equals sine of x, then the derivative f prime of x is the cosine of x. So, we don't want to have to go through that process of deriving this every single time. So we are just going to learn to remember some properties. And one thing that we're always going to make sure we remember is that the derivative of sine is cosine. And the derivative of cosine is negative sine. All right? So we also have derivatives for secant, cosecant, tangent, and cotangent, which we use and we also need to know. And we'll talk about those in our next video.